the proton number, the mass number. Then we also talked about isotopes, isotones, isoelectronics, abi, isobars, and the likes. Then I described allotrope. Then from there, we solved some questions on isotopes. I solved all the likely questions they might ask you on isotopes. So today, we want to continue from there, looking at the work of those scientists on the structure of the atom. Someone discovered the electron, someone discovered proton, someone discovered the nucleus, someone discovered the charge of an electron, even the neutron, someone discovered it. And a whole lot of persons worked on the structure of the atom. So quickly, we want to summarize that too. We are not going to waste time. But the first scientist to talk about is John Darting. So what were the Darting's atomic theory? So that's the first thing we look at. Darting's atomic theory. So number one, Darting said that all matter are made up of what? Atoms. All matter are made up of atoms. So anything you have in the universe is made up of atoms. That's the first theory. The second theory says that atoms are indivisible. Atoms are indivisible. That means when you take atom, you cannot break down atom. But let me just do something on this side and call it the modern theory so that we don't waste time. Now, this day we realize that you can actually divide atoms, abi? So atoms can be divided into protons, neutrons, and electrons. So, and these are called the subatomic particles. But John Darting made us to know that atoms are what? Indivisible. Another thing John Darting told us was that atoms can neither be created nor destroyed. So, but these days, we actually found that we can destroy an atom and we can create an atom. And that happens during nuclear chemistry, abi? So you have talked about radioactivity. And due to the discovery of nuclear chemistry, we found out that we can actually create an atom. So you can start with uranium. And starting with uranium, you start producing thorium, you produce barium, abi, and so on. So you have destroyed the nucleus of uranium and you are producing new elements. And that is what we are saying in that case. So nuclear chemistry made us to know that we can actually break down an atom to give simpler ones. Then number 4, it says that when atoms combine, they always do it in simple ratio. That atoms combine in simple ratio. Atoms combine in simple ratio. That is actually true to some extent. They combine in simple ratio, but the discovery of organic compounds made us to know that no, atoms can actually combine in huge ratio. For example now, simple ratio means that CaCO3, what's the ratio? That is 1:1:3, abi? That is how they combine. 1 atom of calcium, 1 atom of carbon, and 3 atoms of what? Oxygen. I hope you are following. All these are still basics of chemistry and we have a long way to go. So I'm sorry if we are being fast. Normally, it's because of time. You don't have time on your side. Form will be out next week now. And before you know it, the exam is here already. And everybody. And the funniest thing is 28 days is not even complete in February. So we shall manage whatever days we have. That's why we'll be meeting this Saturday. It has to take sacrifices on all our parts. Let's do our best to get it done. And on Sunday, my daddy is a pastor. He will beat me. So for organic chemistry, you can have, let me even just start with the simplest. But you can still have organic compound that has 60 carbons, as simple as it is. So you can't say they always combine in simple ratio. They can combine in huge ratios too. There are some, when you get to study some compounds later, you realize that you can have huge molecules and not in basic ratio at all. So that also proves this theory wrong, that atoms usually combine in simple ratio. Then number 5, what he said again was that when you have atoms, especially if the atom is of the same element, You know, I told you about elements and I told you about atom. Let's say chlorine now. Chlorine is an element, but I can have chlorine 35 and I can have chlorine 37. So this is an atom of chlorine. This is also an atom of chlorine. What this guy now said was that every time you have an atom, they are always alike in every aspect. So he said atoms of same elements. He said atoms of same elements are alike, are exactly alike in every aspect. But the truth is that atoms of the same elements are not exactly alike due to the discovery of isotopes. So what proved that wrong was isotopes. So even if you say that in chemical reactivities, because this is 17, and that will determine its chemical reaction, this is also 17. In chemical reactivities, they might be alike. But look at the mass of this 37, the mass of this 35. So which means the one with mass number 37 is heavier than the one with mass number 35, even though it's the same atom. So they are not exactly alike. Do you get that? So what proved that wrong is the discovery of isotopes. Can you tell me that H11, H21 that we talked about the last time, H31, are they exactly alike? Even though they have the same atomic number and they can exhibit almost the same chemical properties, but their masses are what? Are different. So that's what John Darcy's theory talked about. And these were assumptions, not really guided by a lot of experiments. But later, we started having different scientists work on the structure of the atom. So let's look at all of those scientists and what they did. Can I rub the board? Yeah, let's be fast. So which scientist next? Can I rub the board now? So we are going to have a table. And we'll quickly summarize the work of those scientists. Please, if you know you want to study some competitive courses, always start your preparation early. You know you want to, I always tell students that all of you can gain admission. I can say probably except students that did not want to really go. Last year, virtually everybody gained admission. Virtually. So, but there are some students that they want a particular course, and that's why they had to write that again. So not because probably they didn't gain admission. So if you want a particular course, and you know you need like 350, 320 in JAMB, and you are joining very late, it's a problem. But as much as possible, we'll still try our best to help you. You too, you should try. It does not mean that you join by January, by February, that you can't score above 300. It depends on how smart you are. And being smart does not necessarily mean that you can be smart in relation. When you relate with people, whatever they say, they pass across to you. You try your best. You use every tools around you to quickly learn and put. If it can, you might just be studying past questions and past questions will not come out. So you just have to apply sense, apply brain to everything. That's what I mean. So when you're talking about those scientists, the first person we'll talk about, so let's just look at the scientists, then the experiments they did and what they discovered in a simple form. So J.J. Thomson was one of the scientists. J.J. Thomson did what we call the cathode ray tube experiment. Cathode ray tube experiment. And he discovered something called cathode rays. And that thing called cathode rays today is called an electron. Is that taken? So he performed what we call the cathode ray tube experiment to discover what we call the cathode rays. So cathode rays today are now called what? Electrons. So someone named it electrons. So all those are parts that you will need to know. Now, another thing they can ask you on that this guy is that they can say that what are the properties of cathode rays? I think I've had one video maybe since 2020 on explaining these properties of cathode ray. It's just like 4-5 minutes video. But let me just summarize the properties of cathode ray. So cathode rays always move from negative to positive poles. They move from negative to positive poles in these tube. So you notice that they always move from the from the cathode to the anode. That's why I call them cathode rays, negative to positive. Cathode is negative, anode is positive. Then that was how he knew that cathode rays must have been negatively charged. So to have been moving towards positive, that means they too must have been negatively charged. I will try and share the video. Please, and to those of you that have access to smartphone at home, please, you can we don't use smartphone here. You are not expected to use smartphone class or even bring it to class. So, but at home, if your parents, you can use their own, you can use yours. Please, you can message me either with your mom's phone or either with your dad's phone. So that's my number. So I can add you to the groups. Just say I'm a primary student and this is my name. Please add me to the group. Never say hi or hello. I'm a primary student. Please add me to the group. So I can add you to the primary platform, the students group. We have an official students group. And whenever you gain admission, you should learn to also let me know. We also have a group for all our university students. That's only our university students are there. Then they don't talk anyhow. They are mature people. But your own group, for now, you still talk anyhow. Emmanuel can share the Arsenal one. No problem. But you still caution what you say on the group. So I will add you to that group. Is that taken? So please, 081-679-05541. So I will add you. Just save it, please, so that I can get the information. So today I can share the video on this so that you see the cathode rays and those things in the video. Just what I'm saying. Another thing you need to know is that cathode rays, because they are massive, they have mass, they also cause motion. They cause motion of a paddle wheel. They cause motion of a paddle wheel placed along their path. Oh, you have been coming to class. Why do you watch a chemistry? Are you there? So cathode rays. Now, when he was studying it, he discovered what we call the charge to mass ratio. He talked about the charge to mass ratio. Please note the difference in what I'm saying. Charge to mass ratio of an electron. So charge to mass ratio is different from charge of an electron. So the charge to mass ratio, that's like in 1.746 times 10 raised per watt. I think 11. So coulomb per kilogram. So that's the value of charge to mass ratio of an electron. So when you know the mass of an electron, you can calculate the charge. When you know the charge, you can calculate the mass. So he gave this value of charge to mass ratio. And I need you to note something, that discovery of cathode ray is independent of the gas used in the tube. Please, that statement, you have to note it. They can ask you in JAM. When you see the tube, you will know what I'm saying. He had to be reducing pressure. And he discovered this. Please note that he did this experiment at high voltage. They can ask you. He did it at high voltage and low pressure. The major reason we are doing the class like this, I already told you, is because of the short time of preparation that we have. And we still have a whole lot of things to learn, a whole lot. Even, I'm not sure JP even had time to finish physical last year, Abby, because the time was too short and we have to explain a whole lot of things. So he might not have been able to finish everything. And I think we started September, October, November, December. So we used 4 months and we could not finish it. And now that and that was just physical. So inorganic and organic, they might, and again, by God's grace, by next week, because I've started editing the inorganic and organic textbook very well, properly. That's what I did all through yesterday. So by weekend, if we can print them, so you have them, it will make your inorganic and organic class to be faster and to quickly learn what you have to learn. All of the questions, corrections have been done and edited. So please, is it for free? Yes. Wait, even if I give you for free, what are you going to say? Do you know how much they print books these days? Don't worry, God will take me there. My dream is a day that education will be so free. I'll be teaching for free, give books for free. Everybody, even healthcare system, come to my hospital for free. I know a day is coming like that, by God's grace. So, it does not matter at this stage. Money might not. Honest thing is that even when you do it for free, you will still see money. That's one thing that you don't know. We might decide to do all these things for free, and some people will still take it up on themselves. That, for that year that you want to do it for free, we'll give you 20 million. That has covered the whole year. We'll give you this for free. And just say no. And you might even be the one. There are a lot of primary students we have trained in the past, and a lot of them that are doing well. When they get to that future and they have made it very well, they can look back and say, Sodium, this 1 year, all the students that will come, we don't want to take 1 naira from them. We'll pay the teachers how much, and let's say this is the amount. Okay. Collect an alumni. For me, pay me now poor, you poor. But that is just what it is. All of you now, you will grow to a level that you will just look back and say, 200 Edna, 300 million. But wúrà àti ẹ̀ mo mọ̀ pé wúrà ò lè fún ẹ lẹ́nìtì. Wúrà máa ní ọ́. So can we move on? I think they asked me this one during my job. It's independent of the gas used to. And because cathode rays are negatively charged, deflected, that means they can be attracted or repelled, depending on the condition. So can I rub this part? Please. So another thing you need to know about cathode rays is that they are deflected. Cathode rays are deflected when placed in a magnetic or an electric field. What does that mean? Let's say the cathode ray is released from a source. As the cathode ray is coming, if this is a positive pole and this is a negative pole, because it is cathode ray, what is the charge of the cathode ray? Negative. So it will move towards a positive pole. Do you get that? If it is the north of a magnet or south, it usually moves towards the north. So it can be deflected towards north or towards a positive plate. And that's what we mean by deflection. Do you get that? And that cathode ray is what? An electron, because of the negative charge. So it's being pulled. But if it is a proton, it will be put towards this way. Do you get that? But if it is neutron, it will just go straight. Proton, neutron, electron. Please, do you understand that? So the movement in a field is what we call deflection. So can I move on? Let's move on to the next scientist. These are the major things you need to know about cathode ray. Although J.J. Thomson was said to have discovered proton, but a whole lot of problems are not. Then there's what we call the Plum-Pudding model. We can hear about it too. So the Plum-Pudding model was given by J.J. Thomson. That means he was saying that the electrons are distributed all over like watermelon seed, and protons are also distributed. Those were his theories. If you want to know more, you can just check online. Within 2, 3, 4 minutes, you will know these stories are said, and it will become clearer. So, can I rub the board? So the next scientist to talk about so if they ask you, cathode ray was discovered at what condition? High voltage and low pressure. So the next scientist is Ernest Rutherford. Ernest Rutherford. So what did Ernest Rutherford do? He bombarded a gold foil. That's his experiment. Bombarded a gold foil with alpha particles. He bombarded a gold foil with alpha particles, and he was able to discover a positively charged core. A positively charged core, and that is called the nucleus. So the person that discovered the nucleus is Ernest Rutherford. And what was his experiment? He bombarded a gold foil with alpha particles. Don't let me waste much time on that. There are a lot of stories on that too, how he did it and what he did. To some extent, well, God will help us. So, and don't forget, they can ask you a question on this, that how was proton discovered? When electron was discovered, then the experiments for which are node towards a centrally placed cathode and can cause scintillation on a screen when it hits that screen. So then the discovery of proton depends on what? On the gas that is used in the tube, without saying too much. So the next scientist is, let me say, James Chadwick. James Chadwick. James Chadwick also did beryllium sheets. He bombarded beryllium sheets with alpha particles. Bombarded beryllium sheets with alpha particles to discover the neutron. So if they ask you that who discovered the neutron, it is James Chadwick. The next person is Robert Millikan. So Robert Millikan performed what we call the oil drop experiments. Are you there? God helping us. If we can complete inorganic this week, then physical next week, so we can print that one too. Can I run this? So Robert Millikan performed what we call the oil drop experiments. Are you ready? So what did he discover? He discovered what we call the charge of an electron. Please don't forget, J.J. Thomson gave the charge to mass ratio, but Robert Millikan discovered what? The charge of an electron, which is that negative charge, which is 1.6 times 10 raised per minus 19 coulomb. Abi? So yeah. Most importantly is for you to pick up questions and start practicing. Please, I hope those boys that fought in the hostel, they have gone back to their home. Please, I want to see the three of them if they have not gone home. So today, they should go and pack their load, call their parents, and leave the hostel immediately. And they should not get me angry. The people I've beaten in my life were people that fought and people that stole. So, what will give you the common sense of exchanging punches? You go and continue in your house. There are other tutorials for you to go, so please go there. We don't tolerate that. We don't tolerate fighting and we don't tolerate stealing. When we catch you steal, you are leaving immediately. When we catch you fight, you are leaving immediately. So, are you there? Eh? Your hostel master will still be talking to you until tí gbogbo neighbor bá wá bẹ settle ẹja. Ṣo sọ pé Rambo ni ẹ? You can first come outside kájọ kọ́kọ́ change ẹ̀ṣẹ̀ kó tó máa lọlé. Can I rub the board? So you don't tolerate that. And your parents need not come to beg. There are other tutorials you can go so that you can go and fight very well. I know a place that you can go that even before class in the morning you can take beer, you can take alcohol. Go there. We don't do that here. So the next person is Nebo. Everybody will be fighting by Sheda. But you always want to choose the opposite. You need to note something. And the planetary movement of electron was actually described. Was actually described by Nebo. By Rutherford. The planetary movement of electron, how electron move about the nucleus, was described by Nebo. Was described by Ernest Rutherford. But a lot of concepts being described so wrong and all. I don't even know how modern, how about the new school chemistry. Who has new school chemistry here? Please, for the sake of JAMB, whatever new, it's not because you know, whatever new school says is your answer. That's the textbook that they recommend for you. Because there are a lot of controversies here and there, but I just want to see something. So all the experiments, you can see what I told you now. On Rutherford now, you can see all the stories. So imagine we sit on all those stories. So you can read them on your own. But be wise. You don't have to go and carry textbooks and start reading by this time. You can read all these things and be wasting your time. Just pick important points and move on. I'm trying to see Nebo. So in this place now, the planetary movements was given to Rutherford, even in this description. How electron moves as if it's moving around the planets, moving around, it's given to Rutherford here. So you need to note that. So, thank you. Please return it. Eh? Robert, no. There was no space to write it. Robert Millikan performed a drop experiment. So he did a drop experiment to discover the charge of an electron. So they can ask you about the experiment and they can ask you about what it discovered. So I said planetary movement of electron is done by who? Ernest Rutherford. So you can add that to your notes. That the electron moving about the nucleus, like a planet moves about each other. That is what we're talking about. So Nebo just confirmed that what Rutherford said was true. That's the major thing. He confirmed it that yes, electrons actually are found around the orbits. He confirmed that. Then he now said something that electrons are usually, he did what we call the spectrum of hydrogen. So he used hydrogen spectrum to explain most of his own experiments. So he said something that electrons are localized. They are found at a particular energy level. So every electrons are quantized. Let me put it that way. Are quantized. So if this is the orbits, this orbit here is the K shell. This is the L shell. This is the M shell. So an energy increase outward, not increase from in between. No, I'm just saying that M energy is greater than L greater than K. That K element. That's what I'm saying. This shell, this orbit has a higher energy. This orbit has a low energy compared to this. That's what I'm just saying. So at the end of the day, it's telling us that if you see an electron here, this electron has a particular energy that is associated with it. You cannot see electron here. No, it's not possible. So they occupy a particular location. Electron can be here. But if electron will move from here to here, you know that the energy here is more than the energy here. So if it will move from here to here, it must gain energy. So, which means that for electron to move from lower energy to higher energy, it absorbs radiation. That's one of the things you need to note. So for electron to move from lower to higher energy, it must gain energy. It must absorb energy in forms of light. You talk more about that in physics. That's why you always calculate the energy difference. That you say change in energy is equal to energy of E2 minus E1, or any, depending on the shell. So another thing is that, let me just say final minus C initial. If this electron will go back now from this level, go back to where it was coming from, that same energy that it gains, it must lose it back. So it will now go back to its initial level. So when they now tell you that, if I ask you this, option A, option B, option C, option D, if I'm going from 2s to 2p, I'm going from 3S to 3P. I'm going from 3D to 4S. And I'm going from 5S to 4. Out of all of this, where do we absorb energy? So if you look at this, if an electron will go from 2s to 2p, that means it's energy increase out like this. So those of you that have basic knowledge of chemistry, if you don't know how I wrote this, we are getting there soon. So if I move from this place to this place, that means I'm moving from lower energy to higher energy. Now, will it absorb or emit energy? Absorb. That means this one involves absorption of energy. If I'm moving from 3s to 3p, that's from lower to higher, be absorb. If I'm moving from 3D to 4s, what's that? Emit, because 3D is of higher energy than 4s. It's not about the numbers. It's what you must know. So in this case now, it's going to do what? Emit energy or emit radiation. So if it's going from higher energy to lower energy, from lower energy to higher energy, it absorbs radiation and vice versa. Please, do you understand that? So if it's moving from 5s to 5p now, 5s to 4p, that means it's going from higher energy to lower energy. Then it's going to what? Emit. So in this case, it's going to absorb. And in this case, it's going to absorb. So, and all of this emission absorption is associated with a particular wavelength of color. And that wavelength of color is what you see. So please don't forget, electrons are always quantized. That means they are located at a particular energy level. And if they will leave that level, they either absorb energy or emit energy. Those were the things that Nebo talked about. But we have what we call, can I rub this? Yeah, just for memory's sake, you can write it. So that when you are going through your notes, your brain can say some things. Then when you are solving questions, you start applying them. So don't worry, I will soon stop. So on Saturday, we'll now talk about the rest, quantum numbers. We'll talk about quantum numbers and the rules, and we end it. Then we'll solve all the questions. And if there's any question you have, you can also bring it. So we do that on Saturday. But on Friday, you are writing your tests on everything you have been doing since last week. So you write test again on Friday. I think next week Friday is your mock. So you write mock next week Friday. Then you mark all the exam this Friday. So we're on Saturday, by God's grace. What time should we meet on Saturday? Please. If you know you will not be available, it's not compulsory. Please. We just have to cover the syllabus on time. And we cannot, because of one person, say that, oh, we are not holding the class. So please, we are only using the time we have. But if you don't want us to come, I want to tomorrow, and they will do well. So, but there are some of you that you need help. So don't go on. What time are we meeting? It's 10 o'clock, okay? Yes. So please, when you are added to the group, I'll put a vote on the group, so you can vote for your time on the group. And please, the primers group, the Prima's normal student group, is there abnormal students? The Primal students group, we don't add any other person to it that is not associated with Primax. There is a group for general bodies. That's why I share all this YouTube video and the likes. There's a group for that, and that one is like full already. But the Primal group itself is only Primal students, and you are not allowed to start posting anything anyhow. Don't start posting make 10K in 1 hour. Please. Sometimes we don't remove you because we just give you to do that and we delete your message. But if you are doing that, we will remove you immediately. So please, and if a message is not necessary or you just want to talk anyhow, please don't do that. You don't discuss football there. Just discuss your academics so that you don't disturb others. And if there's any information, you just share it on the group. And it does not mean you need your phone. Don't go home now and say, Mommy, they said we should buy phone. It does not mean you don't need your phone to be on WhatsApp. That one is just whatever you want to say. We will always say it in class. But sometimes we might just vote some things. So it does not mean you need anything. So can I rub the board now? Which things have I not talked about? There's a symbol too. So there is, and please, so that we not have to start asking you that, what is your name? Or what can I save your name as? Immediately, any message you send like this, I might just reply, okay, then I will add you. But if you just say, hi, hello, it's till next year. Just say, my name is, whatever name you say is what I will save your number with. So my name is, I am a primary student. Add me to the group. Anything you can just say, but that you know makes sense. That's the only business. So let's look at the Broglie's wavelengths. So the Broglie gave us something like a paradox, saying that electron can act like a wave, and electron can also act like a particle. So the Broglie made us to know that electron can act as a wave, and electron can also act to calculate the energy associated with the electron. And if electron act as a particle, it means it's formula E is equal to mc squared equation. So 1240. If you want the factorial to come and teach you, you can inform